Our next speaker is Chuck Alpert from Cadence. He leads Agentic AI initiative across Cadence's software stack. Formerly a pioneer in digital implementation, he holds 100+ patents, very impressive, and publications. Is an IEEE fellow and a Cadence master inventor. He earned degrees from Stanford and a PhD from UCLA. And the title of his talk is Harnessing Agentic AI to Accelerate Verification. Okay, thank you.
Thanks. Essentially, it's kind of funny, like we heard from the previous speaker that, AI, what's the place in verification? You still need the tools to verify. But the idea is that what AI provides is the opportunity to work at a higher level of abstraction. The foundation of what Cadence does is our expertise in solvers, right? The decision diagrams, numerical solvers, things like that. And we've built this system of optimization AI based on reinforcement learning over the last several years, and that's deployed in the market. But really the opportunity that we see with agentic AI is working in a higher level of abstraction. Imagine a user, instead of having to know all the nuances of UVM, can just talk to the product and generate the test bench, generate the RTL. So that's really what we're talking about, that this allows us to do. Now, I don't see this as being a replacement for the designer, but an enhancer. We all know about vibe coding and what Claude Cursor can do for programmers. Why can't we do the same thing for verification engineers? And why is this possible? Is because the models are just really getting better, right? Even about a year ago, maybe it's now a year and a half ago, the first reasoning models emerged. And that really just leveled up of the models to solve kind of the specifically coding problems. And verification problems and generating RTL, iterating on it, iterating in test bench is a lot like coding. And so the fact that models are getting better at this really provides an opportunity for us to leverage it for better and harness it for better results. And further, another opportunity that's emerged is the idea that we have common interfaces, right? MCP it's only a year ago, but this is the way that tools that LLMs talk to tools, right? They have a common interface. So as long as you wrap the tool in MCP and register with the LLM, it can discover it. And that's really powerful. Like you might use your ChatGPT and it says searching the web or looking up the weather. These are tools that are provided to it so it can get the real-time information. It's not stuck on the data it trains on. It can dynamically figure out, given a set of tools, what to do. So if we can provide the tools needed for verification, the tools needed to process documents, and aggregate specs, answer questions about specs, this is a huge opportunity. And then A2A is a protocol. ACP is now kind of going away, but A2A is the protocol really for agents to talk to other agents to build a hierarchical. And with this, hierarchical system, with this now, customers can build their own agents. Like the last thing we want to do as Cadence is lock out the customer. We want you guys to be able to have value add. And by providing common interfaces, you can do this. Okay, so this is not necessarily an AI audience, it's a verification audience. So let me give what I consider sort of the basic rundown of what we're talking about here. There's something happened to the graphics. I was a little worried about that when we had to compress the files. That's okay. But level one is what we call optimization AI. This is basic reinforcement learning on top of our systems, right? And I'll talk a little bit more about that. But then once you do that, and we've been doing that for 5-7 years, we have some great tools in this space. Once you do that, you move to conversational. And this is about a static set, talking to the product with a static set of corpus, like the documentation, like the help guides. The users can add things too, right? That's sort of the kind of thing, and that's something we're rolling out everywhere. I think level 3 is where it starts to get really interesting and differentiating, is that now how do you do script generation? How do you talk to the products, like Jasper, for example, and ask it in English instead of just having to write tickle scripts? This is a very powerful idea. But really, in the verification space, agentic workflows, this is where it's just like a self-driving car. we have level 2, level 3 kind of pretty universal today, right? You can't buy a car today without it having a rear view camera system, that alerts you if something's behind you. Or if you're swerving to the next lane, it'll beep and the car will vibrate so you know you're about to hit someone. These are great features that are everywhere. Self-driving cars are here, right? I mean, if anyone see the Waymos around Austin, they are here, but they're on a very limited set of the Earth's surface, and they sometimes don't work. So this isn't pervasive. It's more like a pyramid. So I see the same kind of thing. We are getting toward agentic workflows and verification. This is the most natural place to start. And then, we'll eventually get to autonomy. And what this is showing here on the x-axis is we have these platforms today. We have our Cerebras platform, we have our Verisium platform, we have our Virtuoso Studio platform in silicon, and then we have Allegro and Optimality at the system level. As we start to build these agentic workflows that really can do the self-driving for you, right? It's almost like you almost have one tool. You can imagine you have one tool, like a silicon agent that does everything for you, but you talk to it, and then it'll bring up the various tools underneath, right? Just like you might use your web browser or ChatGPT to try and do everything, and it will go call the tools and get you the information you need. I can see a similar thing happening. Now, again, we're not taking the verification engineer out of this at all. It's about enhancing the ability of verification engineer to be more productive. Given the huge amount of design tasks and the lack of design, this actually productivity gain is a must, right? It's not just enough to say, oh, we get a certain amount of productivity a year. It has to accelerate just for us to keep up. And this is the tool that we think is really going to help on those lines. Okay, so optimization AI. Let me kind of go through the stages really quickly. Optimization AI. Sim AI is our flagship verification project here. If you have a bunch of random stimulus, right, the idea is that you might do a regression, but your random stimulus is overkill. And using reinforcement learning, the next time maybe you can run with 10% less. And the next time another 10%, next time another 10%. And what we see is that with this reinforcement learning kind of production, that we can actually reduce the number of random stimulus by about 10x in cases and get the same amount of coverage. So that's really important idea that we have. And again, it's using sort of the traditional GNN style optimizations to learn as it runs. But agentic AI is different. This is where you're using LLMs, right? You're literally say you have the OpenAI model or the Claude model, and then you pass the context. It's a very different kind of programming. So in this case, what we have is we have a system that can do conversational chats across our products. So the idea is that we have a system to go, now some of our documents are hundreds of pages long, and you have, articles on app notes, user guides, troubleshooting guides. All this stuff is wrapped into a corpus that is in an embedding, and we pull out the relevant context from it. And then, so when a question comes, the first step is pull out the relevant context, and the second step is then take that relevant context and pass it to the LM. If you ask the LM a question about our Excellium product, but the LM knows nothing about Excellium, it's not going to answer. But if you say, hey Excellium, can you answer this question, or LLM, can you answer this question about Excellium? And by the way, here's some snippets from the various documents. We don't necessarily know which ones are good or which ones are bad, but we just pass it a lot of snippets and the answer's in there somewhere, then it can get a good answer. See, that's the magic of this. So we just have to go grab the context as part of this system, and we do this across all our products. Now, one of the challenges here is really deployability, right? Our ecosystem is different. Most of our customers say we will never go off-prem. There's some that maybe allow certain access or certain things, but this is difficult. So we actually have to ship our entire AI platform along with the LMs with our product in some cases. But cloud generally has more advanced frontier models than open source. So it's really a dilemma, but we have to support whatever the customer wants. Now, if we talk about level 3, this is really where we're talking about reasoning. This is dynamically answering questions about the product. So how would this work? You want to ask a question about the RTL. Well, if you want to know something, you could write a tickle script that goes through the RTL. Or you could ask a question about it. We generate the tickle script and run the tickle script and give you the answer. And we test to make sure the tickle script is correct. So that's what I'm saying. The skills of LM to do coding have made this possible. And it used to be that LLMs weren't very good at Tickle, but they're really getting better. So this becomes a viable thing. Now, we have to still do some special things to make sure that they can understand our APIs, but whether our tools take Python or Skill or even Tickle, which is probably the main language of our products, and then even just RTL generation, right? These are languages that are specific, but it's more than just these kind of common languages that we need to get good at. It's also the structured data, the structured input that we need to generate in order to run a design. So, we're starting with RTL, test bench generation, but you can imagine just to even run verification, you have to generate a ton of collateral manually. You have to generate the verification plan manually. So the idea is that LLMs and this agentic AI can go into the space where we really haven't been in order to generate the collateral necessary to run our products. Now, our products are still essential, right? And checking the work with our products is essential, and making sure when you sign off on your coverage and you sign off on your verification, it's real. Right? It's not with the AI. That part still has to be done with the products. But the generation of the collateral is always checked. It's very similar to a functional safety kind of thing. You have other tools to check the work, and that's no different in agentic AI. You generate the collaterals, the core foundation to check the work of the AI system to make sure it's valid. So one of the examples of our level 3 offerings is Verisium Debug, right? Which formerly known as Indago. Now, what this has is it has a lot of core capabilities that are very interesting from an agentic AI capability, such as full hierarchy and design knowledge, access to the database. You can send waveforms. You can explain and perform driver tracing. So there's a lot of rich things. And of course, just chatting with the product. So this is really interesting. And this is available now, right? This is not an abstraction. Now, when you're developing products and we're trying to harness the technology, this is where us as an AI team struggle, right? There's new models announced all the time. And so how much effort do we put into it, right? We can do, the very first thing is, what if an LM can just solve the problem? Just ask it. Yeah, I can ask the LM, and it might get the right answer. Like, for example, with system verilog assertions, I might type a query and it actually knows stuff about system verilog assertions. A year ago, it didn't, but now they're pretty good. Right? So you can start with that. But maybe you just write a really good prompt, right? And sort of guide the LM. Okay, that's good, but it really needs a context, the local context. So you go up to RAG. That's really what it's about. Then there's fine-tuning. But the problem with fine-tuning is then it becomes static on a static LM, and you can only use it for open source. So there's just kind of trade-off between development. Right now, LMs are moving fast enough. We don't see the need for fine-tuning. So that's just one of the things. We can just leverage context. As long as you pass the right context to the LM, that's what RAG really is, then the LM can solve these kind of problems. Okay, so how does this come together in like a level 4 agentic workflow? So we have something called the front-end silicon agent. And what this is, essentially, if you start with a spec or a group of specifications, right, you have to aggregate these and create a knowledge graph of what is in here, right? So the LM can help create this graph, and then you can generate a verification plan from there, right? And that can do it. And from there, you start to generate the collateral, such as the test bench you need. At the same time, you can also take a different path and generate the RTL. And then if you have the test bench and you have the RTL, and depending on how you do this, now you can actually run simulation, or you can run formal methods. So you execute, but you may not get the results you want, right? Or there could be problems. So you have to analyze and debug. This is where Verisium Debug comes in. So what you can see here is a blending of our products, right? Our simulation engine, Excellium, our formal tool, Jasper, our debug tool, our RTL generation tool, Stratus, that goes from System C. We're blending all these products together into a single cockpit in order to verify your design and actually generate your design. Now, if this wasn't enough, we actually acquired a startup recently called ChipStack. And this is a fantastic acquisition. This was only announced officially on Monday. We had a press release for it, so I can now talk about it. But ChipStack has wonderful technologies exactly in the space we're talking about. Now, it's like, our system that I was just describing might be better at RTL. Maybe their system's better at really the spec aggregation. They have something called the mental model. So we're merging our technologies together in order to really get the best practices in this field. So this is very exciting development for us, and the linking is great, and the team's great, honestly. I've already met them all, and I'm just really excited to work with them and to unify all our systems. Now, where are we going with this? Is really, we're going toward full autonomy. So you can see building a hierarchy of agents, thank you, that is necessary. So, we can sort of see that where we're going is you might have a silicon agent, a single cockpit at the very top, and you use these A-to-A protocols to connect the agents together and have the human in the loop interact. All these agents are autonomous, but they always require a conversation with the user about things. But you can just see building this hierarchy could eventually get us there, where we call these tools. So what I was showing you with this level 4 verification could eventually be an entire design platform. That's where we're trying to go. Now, where does Cadence really see this? I mean, right now, if we look at the AI adoption, it's really about infrastructure, spending probably $5 trillion in the next 5-7 years, something like that, on the AI infrastructure and the data platform. It's an obscene amount of money, right? And as we do that, that infrastructure will continue, we're going to continue to invest in infrastructure, but we're starting to see signs of really physical AI. And this will come about maybe in the 2 to 7 year horizon, where self-driving cars are already kind of one form of physical AI, but robots and things like that, you're hearing a little bit about that. But you can imagine about 5 years, these things will become much more pervasive. And it's a huge opportunity. And then after that, and of course, these things will go in parallel. We see the emergence of life sciences, right? That drug discovery, the idea that you can use this kind of thing to solve the kinds of problems we never would have dreamed of before. And maybe even quantum will have a role in there. Quantum's becoming a reality. So it's a very exciting time to look at this space. And we see that, again, we're not trying to build our own LLMs, right? We're not OpenAI. We're not Anthropic. We're just trying to harness the technology that is being developed for our applications. And I think that's a winning strategy. And so, again, at our core, Cadence, we think of this kind of as a 3-layer cake. In the middle layer, this is our foundation. This is principled optimization and compute. I'm talking about the simulation engines, the formal proving methods, the mathematics, the math plus CS in what we do. And then at the bottom level is this accelerated compute. We already heard about all these data platforms, but you can imagine now with the presence of GPUs able to accelerate AI workloads, they can accelerate some of our workloads as well. So we're customizing our models, customizing our algorithms to work specifically on GPUs and get orders of magnitude speed up. So that's really a big development right now. We need our tools to be way faster to work in this agentic AI workflow, and the accelerated compute is one key to that. It's not just like, oh, let's do parallelization, maybe we can get a 2x or 3x. We're seeing, of the order of 10 to 20x kind of speed ups by moving to accelerated compute platforms. And that's why we have these products like Millennium and Palladium, specifically designed for this. And then at the top layer of the cake is really AI. How do we add AI agents to orchestrate all this and to coordinate so we get that next level of designer productivity, which we all desperately need? So my kind of, conclusion is that, embrace it, right? The AI revolution is here. We're developing tools now. Try them out and see, just like if you're a coder today and you're not using any of these coding assistants, you're going to fall behind. I think as a verification engineer, we're providing huge productivity for you with these solutions, and it's important to start kicking the tires on them. And you know what? They won't be perfect, and you might laugh and say, "Oh, this isn't even working." But that engagement, that early engagement, will help make it a reality, and it's happening really fast. So just like you might have tried GPT-3 and laughed at its results, now you try GPT-5 and like, damn, this thing's pretty good. I think we'll see similar kinds of things here. You might engage now, maybe it's not really helpful, but in 6 months, maybe 9 months, it really will be. So I think that's a huge opportunity. But again, I think it's really going to be about upping your level of abstraction, upping the level of abstraction so designers can be more productivity, so we can actually get more done, and that's really what this is all about. Thanks.
Time for one question, if there is one question before we break. Otherwise, we'll go straight into lunch. I think probably lunch is there if you want to go and get your lunch. One question.
Hey, this is Vikas from ARM. So I've been doing validation for like 14 years, and I think the value I add is to find the corner cases and looking at the waveforms and literally getting the human element there that, yeah, this design is working. So even if when we have fully automated like agentic AI, how would we know that chip is really going to work without actually looking at the real corner case scenarios and the data? How would you provide that confidence to your customer? Let's say, even if you reach to level 5, where is the confidence customer is going to be?
So the thing is, what I look at it, again, it's like a productivity gainer. One of the agents we're going to need is like a corner case solver. It doesn't mean you find it, but maybe you have hints, maybe you have ideas. Let's look here, let's look here. And it can be a productivity aid to help you find the corner cases. I'm not saying AI is going to just find the corner case and you just go off and disappear. That's not the case, right? Even today, when you interact with a ChatGPT or something, you're having a conversation to try and get to the answer faster. It's not doing everything for you. It's really no different. It's about how do we utilize this technology to help you be more productive as you search for the corner cases. There's probably a lot of drudgery. I've never done this, but I'm guessing there's a lot of drudgery in what you do. Maybe it can help with some of the drudgery so you can think at a higher level and try and really find them and then get your solution faster. That's the idea.
Thank you.
Okay. All right. Thanks.